welcome to this talk. Today we talking about observability, one of the strongest muscle for SRE. So hello everybody, my name is Jhonnatan Gil. Today we're talking about this. With what part we start talking for myself, who's Jhonnatan Gil or Jhonnatan24. I'm very enthusiastic for Linux, very enthusiastic for the community. Also, I like share a lot of the concepts that I learn every day in my YouTube channel, in my repository, in my Twitter. So please follow me if you want to start with my current followers to take this touch for every read that I take. So welcome to this awesome chair talk about the observability and how we can use for the speed up in our teams. So what more about this? I share with you this awesome phrase. Life is really simple, but we insist on making it complicated by Confucius. This is really, really true because when we have one part of the every challenge that we have every day could be some days more harder than others. So that is powerful. That I liked this phrase from Confucius. So what is the agenda for today? Today we're talking about SRE. Also continue with Dora. What is Dora? How do we can use Dora and continue observability? The golden triangle. Why observability for us? The CNCF landscape and a little demo. So with this agenda, we define exactly what topics we want to cover for this talk and how to, from my perspective, I check and doing in the current stuff for the current job that I done. So first topic, talking about SRE. So the SRE is exactly the desirability engineering. Could be you take this definition for another talks, could be not, but the objective for SRE exactly is for R, the reliability. Because with reliability, we need to think every day what happened with my application, with my infrastructure, with my support, because every day we need every challenge for our application and how do we move more fast for the application and how do we can support that more fast and how to generate that reliability for the application. So I take this definition from glossaries from glossary.cncf.io. That is a very high community for generate this definition. So what is this? Desirability engineering is a discipline that combines operations and software engineering. The latter is applied to infrastructure and operations problems, specifically meaning instead of building product features, desirability engineers build systems to run application. There are similarities with DevOps, but while DevOps focuses on getting code to production, SRE ensures that code running in production works properly. So you have here two mixes for DevOps and SRE, but this is the biggest focus for us. How do we support the code that we generate from DevOps, the result for DevOps? How do we take this code and propose the reliability for that code in production, in staging, or could be in dev, because depend what kind of test I need to generate for every application and how to I can test that application for every part of my software, right? So that is the objective for us. How to make more reliability our components inside of the company and how to make more reliability our teams and how to generate this part very, very useful. So you can read more in depth about this concept. Problem it is for ensure the application reliability, requires multiple capabilities for performance monitoring, alerting, debugging to troubleshooting. So that is the thing that the biggest part here, the performance monitoring, alerting debugging to troubleshooting, right? Because when we have DevOps and we start for the DevOps journey, we enable the capabilities for push the code more easily for every environment, for dev, staging, and prod. But what happened when I have deployed that application inside of the environment that I requested? So then we need to enable another capabilities for that. These capabilities also was called for how do I can see what happened with my infrastructure, my application, and what happened with the communication for the application and the other components that the application needs to connect. So that is the objective and the principal objective for us. Yep. How it helps an SRE approach minimize the cost, time, and effort of the software development process by continually improving the underlying system. The system continues measure and monitors the infrastructure and application components when something goes wrong. The system points reliability engineers so when, where, and how to fix it. This approach helps create a highly scalable and reliable software system by automating operation tasks. If you check in these three part of the how to is SRE, how to SRE helps the company, in every part takes a little part of monitoring or observability or alerting that is part of observability. So that is our focus for SRE. I invite you to read more about the site reliability engineering, especially for the glossary that's cncf.com. That it's very special because it's a lot of community behind of that. So these are little quotes about the SRE, the importance for SRE implementation. SRE is a critical function for ensuring the reliability, availability, and performance of IT system and application. Teams and tools are important to SRE, but equally important is the ability to look at the big picture. The ability to look, right? So every part that we're talking about is, hey, I need to look what happened with my software, my infrastructure, my communication, my networking. So the objective for that, it's very, very, very huge because in every part of SRE, you need to take some concepts about observability. How do you can see that? How do you can take that information for the application, for the infrastructure, for the database, for the message queue or something like that? You need to identify exactly how to your application works and how to your application also was connected for another task or another system. So that is the objective, and this is part why is so important this part of SRE. So with this on mind, we have the DORA metrics. The DORA metrics come from the DevOps Research and Assessment. This is a very huge part for DevOps and also applies to SRE because with these capabilities for this research have 4 metrics, that is deployment frequency, lead time for change, mean time to recover, and change failure rate. From the names could be you generate a general approach for these items, but the most important here is, hey, if I generate this research for my company, what is the objective for that? When you implement and also to take a look for the DORA metrics, you take a look for your maturity, the maturity that you have inside of the company, and what is the capability that you have with generate one new feature, or what is the time that you take for resolve new bug in production, or if production is down, what is the time that you take for recovery for that, and how do you can measure that. That is the objective, because you have here the four components been. But when you move for I start these metrics and start to how do I can measure that inside of my company is the hard part, because you need to identify my repository, identify the process for requirements, identify the repository for features. So you need to take a look for all scopes behind of the IAT process and how do you deliver new features for the clients, the customers, from your internal customer also. That is the biggest part that you need to cover. How do you can see or take a look for from the repository, from the Jira or Confluence, depends for what is your requirement manager for that tool that you use internally or something like that, and take a look. Hey, how do I can take that metrics and how do I can storage that metrics and how do I generate something behind of that for see what happened with one commit or one branch or something like that. That is the biggest challenge behind of that, because every day you need to take, hey, I have a process for generate that. I generate could be a standard for commits. I don't know. You need to identify what happened inside of your company, and if you need to move more than DevOps and generate the next step with SRE, because with the SRE you need to, hey, I get more information that currently I have. I need to start cover for the repository, for the management, for my task or something like that. So that is very, very beauty, because in the way and you addresses your effort for that, you found a lot of conceptually definition that the people has, but not have the really true. So when you start to read and you start to identify and you start to define that process, is a very, very nice path. For other hand, when you identify and you start to call it that metrics, also you take a look for the maturity, right? The maturity mentions to you if you have a low performance or could be a medium performance or a high, or you are a elite. You are a leader for SRE and you have a best practice for the current ecosystem for IT, and you deploy every day or could be once of couple of times during the day or could be in the hour. That is the objective for this research. Identify exactly what is your point and how do you could be moved for the next step, because what is my new challenge for every part of this research. Okay, start talking about observability. So observability is a system property, right? Not is exactly a definition. It's a property that I have in my system to the degree to which the system can generate actionable insights. It allows users to understand a system state for this external outputs and take corrective actions. I think that is the best part for here, because we have currently another tools for generate and take information for my application, but that is observability. Let us check during the session. Computer systems are measured by observing low-level signals such as CPU time, memory disk space, a higher level, and business signal, including API response times, errors, transaction per second, etc. These observable systems are observed or monitored. That is the key, monitored for the past sentence, because currently we monitor it could be because I enable could be in AWS the CloudWatch, or could be I take the logs, or could be I saw the information about the CPU or the throughput for my network. But that is the key for that, or could be just monitor your application. So That is, we're talking in this session. To specialized tools, so-called observability tools. A list of these tools can be viewed in the Cloud Native Landscape Observability section. We will see that landscape in a couple of slides. Observable systems yield meaningful actionable data to their operators, allowing them to achieve favorable outcomes, faster incident response, increased developer productivity, and less toils and downtime. That is one of the par for reliability for SRE. One of the pieces could be the agility sells to us what happens if I generate SRE in my company. Hey, you reduce the toil. That is one of the scope. But the other scope is, hey, how do we can observe? How do we can take that metrics? How do we can generate that dashboard? How do we can generate the ROI for our company? How do we can sell to the managers that SRE is the right path for us? If we have DevOps, could be the next step is SRE, could be, but you need to generate that and identify exactly with Dora the maturity that you have currently. Okay, consequently, your observable assistant will significantly impact its operating and developers' cost, right? You can deliver for another teams, and also the another teams take the most valuable section for that, because you enable the system are observable currently, and also you forget the current, I don't know, could be your charts about the, hey, I need to take a look for the information around for my accounts on production. How do I can take that information? If you observe, you can enable a couple of dashboard and you deliver that dashboard, then the teams can see what happened for the application without access to the current infrastructure. That is a nice part because you enable the capability, and also if you sell that part for security, they open their eyes and hey, that is the way, because they can observe the application, but they don't need to access to the infrastructure behind of that, or could be access to the code or something like that. Just observe what happened inside of that. That is pretty good. When you sell for your company and sell to your manager, what is the best part that you can take this feature key for your team, and how do you reduce the current could be operational task behind of the every needs that the teams has. That is a big one X that is related for the NPM, the application monitoring. So observability is different for application monitoring. We have at this part we talk about the monitored, but it's the same not exactly. That is when we open the path and we generate the bifurcation about what is observability and what is the APM. The APM is the capability to observe, to see, to obtain, but not for generate exactly the impact for the organization, because you just see what happened inside of my components, but you don't put any more for that. But when you start to move for the next step with observability, you start to generate alerts, and could be take that alert and generate could be an automatic task for solve every alert, or solve a couple of alerts that you have identified. That is the biggest difference here between observability and APM. Also exists another ones, but is the part for for split that part, right? We talk about for APM observability. Talking about the golden triangle. The golden triangle is about the information behind of my application, my infrastructure, right? When we talk about infrastructure, we talk about the components behind of my application, database, queues, networking, I don't know, another firewalls or something, another networking tools or elements that you need to know to deploy for support your application. So in what part we need to obtain the logs and also storage that logs. The logs is exactly the unstructured data that provides a record of events and action within a system, right? These logs are typically text-based and are used to configure information about system behavior, errors, and other relevant events. Logs are very useful for troubleshooting issues and identify patterns or trends over time. How do we can obtain these logs and how do we can storage that logs? For the next one, the metrics. The metrics is exactly the structured data that provides a quantitative measure of a system performance or behavior. Metrics are typically numerical values that can be aggregated over time and are used to monitoring key indicators of system health and performance. Metrics are very useful for detecting anomalies, setting performance targets, and making data-driven decisions. So that is for metrics. The next, the traces. Exactly, this is a part of the record for the interaction between components or service within a distributed system. Traces capture timing and context information for each interaction, allowing developers and operations to identify bottlenecks and performance issues. Traces are useful for understand how requests flow through or a system. That is very important because when you have the traces, you identify exactly what is the point the requests go to. For example, you have the access to one login page. When down to the backend, the backend take that request and also generate some operation. What kind of operation? Could be storage, the access to one user, could be read the database for obtain information from the users table, or identify if the users could be is success to login, obtain information around the users. How do you can identify that? You enable the traces, and also how do you can enable the traces? That is the biggest challenge here because you need to instrument your application. That is a key pair for observability. How do you can enable this capability for your application? How do you can enable this bigger scope for the application? So that is very nice part so for discuss with your dev team and also for architecture, because you need to modify could be your framework for the companies, or could be generate a new framework for that, and also you use a pattern for architectural design for that part. That is very nice part because you define with another teams how to the system will be observed, how to you can expose that metrics, and how to you can take that metrics for storage. That it's very awesome and very nice path for you. So why observability? That is the main part of this session, because we talk about observability. Hey, observability seems pretty good, but really I need observability. Really, I need to take advantage for observability. What happened if I don't have observability yet on my company? I have any change for that? Really not. But you have a lot of new features for enable for your teams and also for you when you enable observability. Because, for example, that is a single application that you could be have in your company, that you have here the customer. The customer comes to your application using your cloud provider. The cloud provider you have could be generated here a firewall for identify if the request is legal or not, and you check and identify here there's a couple of load balancer for send the request for the correct application. And also the application here takes that request and generate the logic behind of that request, and could be consumes the database, or could be consumes some requests for your storage. But what happens if this start to that? You move for the next step. You start to split your application, and you split your business capability, and you expand your business. What happened here? You have the same application, or could be every this part is just a little part of the application, and you have here one challenge. Could be you made that, but what happened if start to doing that? What happened with this speedy man, that SRE man, start to identify, hey, the firewall is wrong configured, I don't know, could be the database is down, or replica is down. What happened if my application is down? How do I can identify that? Or could be the load balancer, or could be my region was down. How do you can identify that? Or could be me, my archive has down also. How do you can move for that? How do you identify? So you need to enable observability, because how do you can see that? How do you can take action behind of the application, or the infrastructure, or the components behind and support the application? Because normally when the request fails, you take a look, hey, but the request was pretty awesome to the app. The problem is the app. Then you move the request for the developer team. The developer team, hey, I put that on local, and locally it worked for me. That it's normally, or could be you can reply the same request in development environment or QA environment. In that environment works well. But how do you can see could be the archive, or database, or load balancer, or firewall, or cloud provider is wrong? How do you identify that? That is exactly the question for that. If the application works well, of my components work well for the application, or my infrastructure was well, hey, how do I can take a look for that? I need to take this very, very important observe system for my company, right? So behind of that could be exist another components like a DNS, or could be generate your security compliance, or you generate a new fixes, or you could, I don't know. Every day you need to cover new features from the different users, not for the customer, just for different users, like a security could be for a compliance for the loyal from your company, or something else. Yes. Then how do you can identify exactly in what point the application was wrong? Then you can observe that system, and you identify, hey, yesterday we made some little changes about for new loyal support that request the company. So when we deploy that, the component for firewall could be wrong. Could be the security team generate a new feature also, because they need to also update for the firewall, or the security group, of the rule behind of the my load balancer. Then the application start fails. So how do you can see that? Again, with observability. Another part for observability is alerting. It's not when we observe, it's just, hey, I can see. But when you enable observability, you observe and alerting for that. When you start alerting, you start to move more in the observability ways, right? That is the objective for observability. Another is, hey, we need to take a look for dashboard. We need to automate some remediation for X case or something like that. Could be you move for observability as code. There is a new moves for our companies when you could be auto instrument the application, or could be you have and generate an cluster for Kubernetes, and Kubernetes had an operators inside of that and take information for the applications and generate that auto instrumentation for you. That is one way for doing that. So bye little Speedy, and start wrote about the CNCF landscape. That is very huge tools about the observability and monitoring. Here we have also the every tool the every cloud provider has enabled for day. So we have the Amazon CloudWatch, App Dynamics, application availability service, application manager, App Data, App Optics, App Signal Alternative, Azure Monitoring Bits. You have here a lot of tools for the community and how to the biggest company use that for their services. In another, how do you can use for logging? You can use Graylog, Umio, Logi, Logly, FluentD, Grafana Loki, or Elastic, or Logstash. You can enable, depends for your expertise, or could be you need to take a look more in depth about this landscape for define the current stack for your company, right? How to move for tracing? How do we can enable tracing? Hey, there is a very huge community behind of this component that is OpenTelemetry. The community behind of that is the second community bigger behind of Kubernetes spheres. Second is OpenTelemetry. I recommend to you take a look for this community, and also they are very active community for generate every day some new feature for you, and also supported a lot of languages for you and components behind of. Okay, another part is for observability and talking about chaos. Yeah, chaos is part for observability. Then we need to take a look for that. But it's pretty awesome. You here take a look for the landscape for CNCF. That is what happened here. And also information about the continuous optimization behind our observability. Take a look for, hey, how do I can fix that? How do I can take that log? How do I can take that trace? You enable another capabilities when you start to generate that journey for observability. You also enable the capability for the cost optimization, because you see, hey, I take could be a one instance that has overloaded for the application. That it's normally or not, or could be identify the pod that you deploy in Kubernetes cluster are overloaded too, or could be you generate an HPA definition for that, or could be you identify the process that they execute could be moved for the another node. So that is another capability that you enable when you start the journey for observability. But then you need to take a look for your company. You need to take a look exactly how do you move for that part. But first, you start to define what is observability and how to the company use observability inside of that, right? So we move for the demo session, that is the repository. If we click here, we move so fast for the repository that is here. And also you can see here the information about the how do you can execute this demo. For that part, we are able the capabilities for Docker. You need to install Docker first. For that is this disclaimer. Don't run this in production, because it's not for production environment. It's just for locally. It's for your POC and identify how you can enable observability for the Docker stages, right? So we deploy first the C advisor, second Prometheus, and third Grafana, right? So with that in mind, I put here some reference that I take for doing that, and reduce this README file for you. And also the license here is Apache license for you and your time and your team. You can put and drop this for your code, and I don't care. That is part of the exactly what happened when you work with the community, right? So I clone the repository here. You can also download the repository with, let me check here, when you see git remote PNB, you see here, that is the current information about the repository that I cloned. And also we have their files here. And I have one extra folder because in the README file, we talk about them exactly for this part. When you try to optional point, that is for workloads for your Docker environments, I downloaded before for doing that more easier for you. So, and also I drop some information here in the git ignore for don't put this folder because it's just for using when you download the folder and not for generate garbage for the repository. So with that in mind, we start to execute the instruction inside of the repository. The first is install C advisor. So let me check here, docker ps -a. We have here C advisor before Grafana and Prometheus. Let me remove that. Docker C advisor, Prometheus, and Grafana, right? That is the optional point. That doesn't matter about that. Docker ps -a. And here we go. We clean our environment. So the first part is install Docker. Install C advisor. What is C advisor? C advisor is could be a proxy for obtain metrics from the current Docker installation and sends to you and export that metrics, right? When we move for the presentation here, we have the localhost access here, so we can copy and paste for the new tab. Here we go. We have currently metrics that are the C advisor taken from the current deployed from Docker environment, right? So the next one, that is the GUI for C advisor, and this is the current metrics. That is a lot of metrics that you can see here because they take these metrics for Docker and move and expose for you can use for your preference, right? For that preference, we enable Prometheus. So we copy the Prometheus YAML file, but what contains Prometheus YAML file? Let me see here. That is the Prometheus YAML file. For that part, you need to check what is exactly your IP internal address for that deploy. For my case, I doing that. And also, we can start for deploy this part. So we move for the Prometheus part here. cp Prometheus conf42 TMP. And also, we can start to run the Docker environment. So let me pass the command here. So we enable Prometheus and enable the port 9090 and mount the Prometheus conf for the container and drop to etc Prometheus YAML. Yep. And also the image that we use is from Prometheus. Here we go. Then Docker PS, we have currently two services in Docker. What is CAdvisor? That is read the metrics about these metrics. Could be Docker stats. Docker stat. And that is the current metrics behind of that. When we up the optional point, we see more metrics here. Okay, the next point is, hey, we need to take access to what kind of metrics we have and cover that for the part of Prometheus, right? What we see here exactly the status for the components, the configuration. I have here the information about the script configs for metrics, exactly for the current metrics, and also the metrics for CAdvisor for my internal IP address, right? When you see exactly the current metrics here, graph, no alerts, no status, runtimes to configuration, command targets. We have up two endpoints. That is for CAdvisor, and this is the endpoint, and the endpoint for Prometheus that call it metrics currently exactly for Prometheus. So here take the name for the current Docker name, localhost here, and localhost. You see another metric here. That is, if you follow the instructions here, you need just copy and paste. That is more easily way for that, right? That is for targets. When you saw the targets, you can check exactly the same way. So we need now deploy Grafana for see what happened for Prometheus, because hey, that is very awesome. The metrics, it's a text based, but I sincerely don't have time for read that. That it's very normal. We can copy this and move for the demo session here. Here we go. Docker PS. We have currently Grafana in the port 3000. And move for the presentation part. And also copy. Okay. And open Grafana. Here you need to access for your Grafana account. That is admin. That is all our default passwords for us. And admin. Here we go. We have access currently for Grafana. That is pretty awesome, because you have, hey, that it's very, very nice ecosystem for us. And you see here exactly the Grafana. Let me move here at this part, because the presentation could be doesn't work well. Okay, that is the first part. When we move for the repository, we see here, hey, we need to generate a couple of configurations inside of Grafana. So could be that part is very wrong here, but you can move for the raw file, readme file, and move for the go to in raw mode, that is most readable for you, right here. So down here, and we enable first, go to administration, data source, add a new data source, select Prometheus, in URL drop HTTP your IP 9090, navigate to bottom, save and text, and done. Right, let me drop here this and move for that. So how do we can move for that? Here the 3 lines on the top. Okay, 3 lines on the top, that part. And move for the administration here and data source, right? When you start here, you can add here a data source and select Prometheus. That is all the configurations. Then you need to put here http 2 points / http points / that is my IP. That is take the information for Prometheus. Will be copy and paste here and just change the port, right? The port is 9090 that we saw in the current information here. Your port 9090. Okay, I can navigate to the bottom, save and test. That is the green. That is awesome for us because green seems for us everything going well. Okay, return to the home because the next step is enable exactly the new dashboard that we need to take a look for day. So let me move it here very quick, and also we execute the information about here. That is the reference, but we deploy these monitors for our system. So for that, you can access for this HTTP page, and also appear here what is a little thumb for the dashboard. You copy the ID to clipboard and also move here. How you can import that dashboard? Move for the 3 lines, move for the dashboards here in the news section. Let me move here this pretty quick. And this in the new part, you move for the import, paste here exactly the ID that you copy in the previous page. Then load. That's the page that loads. You select exactly your data source, that is Prometheus, and the name could be you can change, or could be you generate a new folder for that, and import. And voila, that is information for the current metrics inside of Docker. That it's pretty awesome because you can see here exactly what happened with your Docker. But here it is another information for Docker and monitoring for using Grafana 2. So you can copy that, and the same way. 3 dashboards, save changes, new, import, paste the information for the another part. Here you need want to change, Prometheus, and import. And voila, there is another dashboard that you can see the same information with another view. That it's pretty awesome because we enable the capabilities for observe our system, right? That is the first part. But with Grafana and also with Prometheus, you can move here very quick and generate the alerting. And you can drop here your alerts. You can drop here the rules that you made more sense for you and your company, how to the behaviors you identify exactly for the current Docker or your application or your cluster of Kubernetes or your infrastructure. You have the possibility to enable here all alerting that you have. Also, you can drop every rule here in the contact points. You have a lot of ways to deliver that information for using Alert Manager or communication with another ticket manager, or using Discord or email, or could we put that for Kafka or PagerDuty, or send an alert for Slack for your team, or generate alert for Telegram or something like that. You have the capability for connect Grafana with all scope for your current stack, for your IT infrastructure. So that is pretty awesome, the webhook, because with that you can have the capability to send to another, don't support exactly a tiered provider out of the Grafana, and you can send the information for the alert and what happened with that alert and generate there could be a custom payload for that. And since just the information related and more valuable for you, and the alert will be more great for you, right? So we can move here very quick. That is the demo. Please tell me the comments or what appear for you this little demo. Appear resume for observability. Observability is a hidden muscle for SRE success. We need to enable observability for our companies, how to the observability made more bigger our teams, how to we can enable another stuff for the company. And also what is the brief resume, SRE and DORA, observability, what, why, triangle, alerting and remediation that we're talking about, and a little demo. Some practice for observability, that is another part, that is effective observability requires focus on business value. That is the objective for that. And alignment with organizational goals and a culture for continuous improvement. How do you can fix and how to the objective for observability is the same for the company, not just hey, I have one way to generate observability stack, but the company doesn't need observability. I don't know, could be you need to take this more in depth with your company. Another is the best practice include investing in the right tools, prioritizing data quality, and embracing collaborative and data-driven approach. That is another that you can enable for the observability. And thank you. That is all for this session. Please feel free for dropping the comments or contact me here with Jhonnatan24 for GitHub or YouTube or Twitter, or if you can find me like a Johnny Pong in LinkedIn. Please feel free to contact me. I have sometimes for response to you. So thank you for your time. I hope you have enjoyed this session. Thank you and see you. Bye bye.